Hi, my name is Hezi Sar, Director of Product Marketing.
Hi, I'm Gervais Fong, Director of Product Marketing. Hezi, what are we here to talk about today?
We are here today to discuss market needs in mobile and consumer SoCs as they relate to interface IP. The diagram shows a typical high-end application processor targeting mobile phones and drones. There are basic functionalities such as chip-to-chip and memory connectivity that are satisfied by PCI Express and DDR interfaces. For embedded displays, MIPI DSi and DSi2 on D-PHY is the common interface used to implement higher bandwidth, higher refresh rates, and support multiple displays. Synopsys offers complete support for DSi and DSi2 host and device controllers, as well as D-PHY and C-PHY D-PHY combo solutions. VESA DSC is offering visually lossless compression. It is used with MIPI DSi and DSi2 to reduce the transmitted bandwidth and to reduce the system implementation cost. We at Synopsys support DSC encoder and DSC decoder cores version 1.1 and version 1.2 that are interoperable with the MIPI DSi DSi2 controllers, DP EDP controllers, and HDMI IP. There is a lot of innovation happening in the number and capabilities of cameras used in mobile electronics today, such as the 100 megapixel camera that was recently introduced. We see many cameras used in front, inside, and back to enable presence detection, depth sensing, wide angle, better zooming, as well as super selfie. We offer support for CSI2 host and device controllers, as well as D-PHY and C-PHY D-PHY combo in a variety of process nodes. We also support automotive grade 1 and grade 2 IP relevant to the CSI, DSI, D-PHY, and C-PHY D-PHY IP that is used by many customers in production, including our ASIL-B-ready CSI and DSI controllers. The number of sensors increases in mobile applications to enable a variety of motion, biometric, environmental sensing, and other capabilities like that. The latest interface i3C helps to improve system efficiency on this front. Our i3C cores can be implemented in SoC and on sensors, allow to have multiple sensors connect on the same bus with reducing the number of pins as commands and interrupts are implemented in band, dynamic addressing, and providing backwards compatibility to I2C. Gervais, how about USB in mobile?
Thanks, Hezi. It's really exciting time in mobile, specifically with especially the high-end mobile phones and tablets going to like 5 nanometers and soon beyond that. There's got to be development to be able to extend USB to support it. So USB has always been backwards compatibility. That's one of its key differentiators and strengths with regards to its wide appeal. So what I mean by that is specifically on USB 2, once you go to 5 nanometers, it's very difficult to support the traditional signaling levels, 3.3 volts for USB 2. And so what we've done is Synopsys has been part of a group of companies that have worked with the USB-IF to develop what's known as the eUSB 2 standard. And that standard is needed to be able to have USB 2 connectivity at 5 nanometers and below. We've developed the PHY that supports that. We've proven it in silicon. We've interoperated with other third-party eUSB 2 partners in the industry. We're the only company in the industry that has done interoperability with multiple third parties. And so with that capability, we can provide that to the high-end mobile designs that want to design at 5 nanometers and below, as well as if they want to use eUSB 2 and 6 and 7 nanometers, we can also support that also. Complementing the eUSB 2 is also in the mobile phones and the tablets. It's only typically a single connector. And so the latest USB connector standard, USB Type-C, is ideal for these types of designs. What I mean by that? So there's a USB Type-C, what we can offer is like a 3.1 combo with a DisplayPort PHY. Paired that with the respective USB and DisplayPort controllers, we have a complete solution that we can provide in 5 nanometers, 6 nanometers, 7 nanometers, 12 nanometers that will enable these types of mobile designs to be able to take advantage of the latest USB standard of 10 gigabits per second with USB 3.1 and DisplayPort 1.4, which runs up to 8.1 gigabits per second. With that complete solution, we really are enabling the connectivity of these mobile devices to the outside world with data, power, and video.
Thanks, Gervais. For embedded storage, we see two options. eMMC is still common in mainstream phones due to its low cost, while UFS is gaining more momentum, and it is the de facto standard in high-end smartphones. And now we also see it entering into the mainstream phones due to its high efficiency and more capacity. And for removable storage, SD is still the dominant removable card, while we do recognize the introduction of UFS cards, which can be found in some mobile electronics today and even laptops. We support complete solution for SDMMC version 5.1 with a controller and hard PHY available in 28 nanometer down to 5 nanometer. For UFS, we support UFS 2.1, UFS 3.0 solutions that include the UFS host controller, Unipro version 1.8 controller, and MPHY version 4. All of them are proven in a variety of nodes. Synopsys also leads the MIPI Unipro workgroup and active in MPHY and UFS workgroups to drive the next UFS 4.0 specification. We provided you a snapshot of interface IP that can be implemented in mobile and consumer applications.
And we hope you found this informative. So on behalf of Hezi and myself, we want to thank you for watching.